In this example, we're going to calculate in part A the root mean square velocity of a carbon dioxide molecule at 25 degrees Celsius. And in part B, we're going to calculate how many times this molecule travels horizontally across a room 6 meters long every single second. So let's begin with part A. Recall that a carbon dioxide molecule is composed of a single carbon atom double bonded to two different oxygen atoms as shown. So the carbon atom has a mass of 12 unified atomic mass units, while each one of these oxygen atoms has a mass of 16 unified atomic mass units. So the total mass of our molecule, of our carbon dioxide molecule, is 2 times 16 plus 12. That gives us 44 unified atomic mass units. Now, recall that one unified atomic mass unit has a mass of 1.66 times 10 to the negative 27 kilograms. So that means the actual mass of a single carbon dioxide molecule in kilograms is given by taking the product of 44 unified atomic mass units and 1.66 times 10 to the negative 27 kilograms per unified atomic mass units. The U's cancel and we're left with a value of 7.3 times 10 to the negative 26 kilograms is the mass of a single carbon dioxide molecule. So, now we apply our equation for the root mean square of our velocity of the carbon dioxide molecule. So the magnitude is equal to the square root of the product 3K times T divided by M, where K is the Boltzmann constant, T is the temperature in Kelvin, and M is the mass of our molecule. So 3 multiplied by the Boltzmann constant, 1.38 times 10 to the negative 23 joules per kelvins, multiplied by, to find the temperature in kelvins, we simply add 25 and 273 as shown. So we multiply these two values by 3 and divide that by the mass which was found in this section. So 7.3 times 10 to the negative 26 kilograms. We take the square root, or raised to the power of 1/2, and we find that the root mean square velocity of our carbon dioxide molecule at a temperature of 25 degrees Celsius is approximately 411 meters per second. Now let's move on to part B. We want to determine how many times our molecule goes across the room when the room is 6 meters long every single second. So first we want to find the total distance our object, our molecule, travels when it travels horizontally. So it travels across, bounces off, travels back, and continues doing so every single second. So in 1 second, the total distance traveled is, well, it's the root mean square velocity, 411 meters per second, multiplied by 1 second gives us 411 meters is the total distance traveled by our molecule. Now, to find the number of times our molecule goes across the room, across a room that is 6 meters long, we simply take 411 and divide that by 6 meters. And we see that it goes across the room 68.5 times, so about 69 times.